Hello everyone and welcome to DhiNexus. My name is Oorja Chandravanshi and in today's session we will be learning about metals and non-metals. So this is a chapter of class 10th NCERT. At DhiNexus we try to make learning fun, engaging and so stay tuned till the end of the session. Let's have a look at what all topics will be covering. So first we'll start with classification of matter so that we are able to understand better as to what is metal and what is the difference between metals and non-metals and how are they different from elements. Actually, metals and non-metals are a part of elements, but we'll have a look at it. Then we'll extensively see about the physical properties of metals and non-metals, of which the most important part is the exceptions, since a lot of questions can be found out from. For example, what kind of metal is a liquid at room temperature? Or name a metal which is liquid at room temperature at all times. A metal which can be cut with a knife. And another non-metal that can be used to conduct electricity. So if you know these answers, well and good. But stay tuned to have a full list. Chemical properties of metals, that will be the next topic. With oxygen, with water. If time allows, we'll also have a look at what its reaction with acids and solution of other metals. And lastly, we'll have a look at reactivity as to which metal is going to replace the another one and how does that take place. Let's get started. First, let's understand matter. This is a fundamental part of chemistry. And actually, everything around us is matter. So, matter is anything that has mass and it occupies space. How do we classify matter? Pause the video for a minute and try and list all the classification that comes in your mind. Student always jump to the conclusion that it is going to be solid, liquid, and gas. But please hold your horses. It's going to be not just that. That is physical classification. Basically, how the packing of atoms is. Is it close, very close to each other? Then it's going to be a solid. If it is a little bit far away, it's a liquid, and further far away, then it's a gas. There are two other more types of states of matter that we must know about: Bose-Einstein condensate and plasma. I would urge and suggest everyone to do a little bit of research about all of this and what are the conditions where we find these states of matter. Next is, and the most important is, chemical classification of matter. So, on the basis of chemical classification, we first see pure substances. And next is the impure substances, something which is having a mixture of atoms together. So what do I mean by pure? Pure does not mean that it is free from any impurity. Pure means that the atoms are binded so close to each other that they are not able to be separated by simple physical or chemical methods. Like you cannot do this evaporation and try to solve the atoms. No. Mixtures, however, for example, I take salt and sugar. Now it is quite easy to separate salt and sugar because sugar granules are bigger in size and quite easy to separate from your hand. But if I say separate hydrogen atom, that's not something that can be done from hydrogen molecule. That is not feasible. So this also has two types: pure substances, elements, and compounds. So in this pure substances, the atoms are bound in a fixed ratio. So here I have only one type of atoms. Only one type of atoms are there, then it will be elements. And if there are at least two types of atoms, then it is a compound. And compounds can be of two types. You can have organic or inorganic compounds. Inorganic compounds is everything that we think of when chemistry comes to our mind, like HCl, NaOH. So these. Organic is what we're made up of, or like the food that we eat. So glucose, for example, C6H12O6. This is an organic compound. And elements. So this is what we want to know about. The classification of elements, basically. So let's dig. As already said, elements are substances which have only one type of atom. And this covers metals, non-metals, and the third part, which is metalloids or semi-metals. Now, metalloids or semi-metals are substances which have property falling in between metals as well as non. But something we won't be discussing in this class. So let's see metals. So example would be, suppose I have sodium metal or magnesium metal. And non-metals can be a chlorine gas or oxygen gas. Now, how can I, physically understand, like, if I see a substance, is it metal or is it non-metal? How can I distinguish? And what separates them? So for this reason only, we study about their physical properties as well as chemical properties. Like a simple example when metal comes to our mind is that we think of an iron bar. And what can you say about the properties of an iron bar? Like, why is it different from a wood? Or why is it different from a glass? So the reason is iron bar is shiny in nature. It is shiny. It has, when you try to struck it with a tongue, it gives a ringing sound. That is sonorous. So let's see this in detail in the next slide. Physical properties, and basically we'll be covering physical state, luster, hardness, sonority, density, solubility, melting and boiling points, and some more. So let's see. If I look at a substance, a metal is going to be one which is solid at room temperature. So iron, again, a simple example, it is solid at room temperature. It does not seem to be in a liquid state. There's an exception to it, however, mercury, which is written as Hg and also used in thermometers, is a liquid. Gallium, it turns into a liquid above 30 degrees. So gallium is represented by G. Even on placing at the palm of your hand, why does it turn liquid? It is because our body temperature is around 35 to 37 degrees Celsius. Non-metals can exist in all the three states of matter. That is oxygen, nitrogen, chlorine. These are gases. O2, Cl2, and N. This is how we represent them. And this is also called as the elemental state. That means in the environment, they're going to exist as gases. Like they are so reactive that they cannot be left. For example, I cannot just leave oxygen. A single oxygen atom, also called nascent oxygen, is highly reactive. Hence, it combines with another oxygen atom to give us O2. Bromine is liquid and phosphorus, sulfur, carbon. These are solid. Moving on, the luster. So metals are lustrous, they are shiny and they are polished. Lead, however, being an exception, is a dull. Non-metals are non-lustrous, they don't have a shiny surface. Except, however, there's diamond, graphite, and iodine. These are lustrous. And diamond is, adored by everyone for its lustrous. A classic example. Then we have hardness, metals. Again, stop. What comes to your mind when you think of hardness and metal? That it is going to be hard. However, sodium, potassium, these are some soft metals. So soft that you can cut with a knife. So if you didn't know the answer to the initial first few minutes when I asked you, I posed this question: which metals are so soft they can be cut with a knife? Now you know. Sodium, which is Na, and potassium, which is K. Solid non-metals like sulfur, phosphorus, these are soft. Sulfur is S, phosphorus is P, and carbon, which is in the form of diamond, it is one of the hardest naturally occurring substances. So carbon actually has three atom forms. It exists in the form of diamond, then graphite, and Buckminster fullerene. So carbon can be called a hard substance. Sonority, again, as I said, if you try and struck the substance with a, for example, if I'm strucking metal like iron bar, it will give a ringing sound. Ting, this sound of, a distinct sound comes. But if I'm trying to beat this table, there's no ringing sound. These are non-sonorous and don't produce any. Next is their density. What is density? How do we understand density? It is mass upon volume. So metals have high density, sodium, potassium. However, have low density. In fact, so low that they are lighter than. Non-metals in general have low density, of course, exception being iodine, graphite, diamond. These are substances of high density. Are they soluble? Are metals soluble? No, they are not soluble in water or other organic solvents. What are other organic solvents? So, for example, you can take C6H6. This is benzene. This is benzene and it is an organic solvent. What about non-metals? These are possibly soluble in some cases and insoluble in water or other organic solvents. Melting point. So metals, as they have a high packing efficiency, these have high boiling point. So it is difficult to separate the atoms, which is why they are found to have a very high melting as well as boiling point. Examples of exception would be Na, sodium, potassium, then you have gallium, cesium as well. Cesium, this metal is found in the group 1 of periodic table. And we have Hg. What is Hg? This is boiling. Non-metals have low boiling and low melting. Graphite, diamond, these are substances which have high boiling points, melting points. Reason we've already discussed, that they have high packing efficiency. Let's look at some more. What does ductility mean? Ductile means something which can be drawn into wires. So metals are actually ductile. They can be drawn into wires, which is why we wear gold chain, silver chain, and copper wires are used for electrical fittings in our house. Non-metals are non-ductile. Of course, exception is carbon fiber. So carbon fibers are extensively used in, and a lot of scientists are doing research on it. I would suggest you to do a little bit homework on what is so special about carbon fibers and where are these used. Now, malleability is the cousin of ductility. Basically, you can draw them into sheets. So metals can be drawn into sheets without breaking. So the ability to break, that is called brittleness. This is brittleness. So metals are not brittle except zinc. When you try to mend it, it will break into pieces. Gold is one of the most malleable substance, most malleable metal. Non-metals are brittle and they're not malleable. What about thermal and electrical conductivity? So metals are good conductors of heat as well as electricity. Silver amongst them being the best. Then you have copper and aluminum followed. Example of exception is bismuth. We have bismuth, then you have lead, It is a poor conductor of electricity, does not conduct electricity. It does conduct electricity, but to a very less amount. So there's a difference between being an insulator as well as a poor conductor. Please make a distinction about it. Don't get confused. Mercury, bismuth, these are poor conductors of. Although student once asked me, why do we call mercury a poor conductor of heat, although it is used in thermometer? It is a poor conductor of heat, not that it does not conduct heat. Poor conductor, not very much as compared to iron. So non-metals, these are bad conductors. If they're not good. Carbon, however, in the form of graphite and in gaseous state is able to conduct electricity. So tensile strength, what does that mean? So metals have high tensile strength. That means they can bear a lot of strain. Like if you try to put a lot of load on it, it won't break. See, as we already saw in the earlier point, in the malleability part, zinc is brittle in nature. Hence, it won't be able to take a lot of strain. Non-metals have low tensile strength. They will break or they will bend when we're trying to put a lot of load on. Exception being carbon fiber. Again, this means that it must have some connection. Where is carbon fiber used? See its application. Last is alloy formation. Now, what does alloy mean? Alloy means when you're taking one or two metals and you're combining their properties so that you get another substance. What is a benefit of it? You get two properties of two substances and it becomes useful. So these alloys are called actually homogeneous mixtures. These are homogeneous mixtures. And non-metals do not form alloys. Carbon forms an alloy with iron, however, forms something called as steel, which is extensively used by all of us. So this marks the completion of physical properties. I hope now you'll be able to tell me which substance can be cut with a knife, which substance is liquid at, which metal is liquid at room temperature, and which metal turns into liquid at room temperature. Which non-metal is liquid and which one is gaseous. And the non-metal that can be used as an alloy. So answer these questions, pause the video and see if you remember it. If not, see the table again and learn. Let's start with the chemical part. Which includes, the first one is oxygen. Any metal which reacts with oxygen is going to give you metal oxide. MO here means metal oxide. If you take copper and heat it with oxygen, you get copper oxide. We learned in the first chapter of NCERT, that is balancing equations. We see that copper oxide is black in color. So an important distinction. Always remember, always make it a point to note down all the colors or all the special reactions, which is going to tell you about what kind of PPT you're getting, or if a particular reaction shows H2 like this. What does this arrow indicate? It tells us that there's evolution of gas. So maybe bubbles are formed, or if CO2 is given. So it will show brisk effervescence. So these properties are really good. Then I have aluminium. Aluminium on reacting with oxygen gives aluminium oxide, Al2. Now we've learned that metal oxides are basic in nature. But is that true universally? Not one. Aluminium oxide and zinc oxide, so Al2O3, and ZnO. These are amphoteric in nature. What does amphoteric mean? Amphoteric means something which can react both with acids or base. So, on reacting with acid, it gives me AlCl. On reacting with base, it gives me sodium aluminum. So, this is an important example found in NCERT. Please note it down. So, both Al2O3 and ZnO are amphoteric. Then there is a case that some oxides, metal oxides, like your sodium oxide and potassium oxide, usually metal oxides are not soluble in water, but these are exceptions. When they are put in water, when they're dissolved in water, they give us something called as bases which are soluble, and such bases are called alkali. The bases which are soluble in water are called alkali. Moving on, we'll see about water. Water, when reacts with metal, gives us metal oxide and hydrogen gas. So this is giving me hydrogen gas. And this metal oxide on reaction again with water is going to give me metal hydroxide. Which can be MOH or MOH pulled twice, and so on. Let's see some example. Potassium and sodium. Both of them, when react with water, they show such a violent reaction that we can, sometimes that it shows to catch fire. So it is a highly exothermic reaction. We get, suppose I'm taking K, so KOH plus H2 plus heat energy. So whenever heat is evolved, such reactions are called exothermic in nature. So this reacts very violently. Next is the reaction of calcium. So calcium, it does not show a very violent reaction. It shows formation of metal hydroxide. Along with evolution of. In fact, this substance is found, basically calcium is found to float on water. It starts forming bubbles of hydrogen. So calcium floats on water and it sticks to the surface of metal. So again, magnesium, and it does not react with cold water. Cold water, no reaction. But it reacts with hot water. And what do we get? MgOH, cold twice, along with hydrogen. And it also starts floating due to the formation of bubbles of hydrogen gas which stick to the surface of the metal. What about other metals? Like what will be the reaction of aluminium, Al2O3 plus H2. Now remember, aluminium, zinc, iron, these neither react with hot water nor with cold water. So what do they react with? What is this reaction that occurs? This is the reaction with steam. They react with steam instead. And we get metal oxide and hydrogen. What about substance like copper, gold, and silver? These are not found to react with water, because if they were reacting, then we wouldn't be using them as ornaments or, as electrical fittings, right? So this is not found. Moving on, we'll see reaction with acids. So metal on reacting with acid gives us a salt and hydrogen gas. Now, why do we get a salt? If you see, this is slightly related to the reaction of neutralization, where metal, if it is acting as a basic oxide and reacting with acid, will give us salt as well as a hydrogen gas. So I can get, suppose I have metal A plus salt solution of B. Then I will get So in today's session, this is all we'll cover. We'll see the rest, that is reaction with acids and other metals, along with reaction with reactivity series in the next video. If you found this video helpful and if you thought that this was something that you should, share it with your friends so they can benefit, then please do so. And subscribe it to the channel so that you don't miss on the upcoming videos. Thank you and have a nice day.